All right, we are going to look at the moment of inertia for a physical pendulum. Now, my physical pendulum is made up of a bar with a disc attached to it. Now, I made the mass of the bar m, the mass of the disc also m. The length of the bar is 2r, and the radius of the disc is r. I just used these values just so things would kind of go together nice. So to find the total moment of inertia, I have to add up the moment of inertia of the bar and the disc. And now I'm going to show you how to get those two moments of inertia just as a nice little review for you. So I total for the moment of inertia of a bar, because it is a uniform bar, we are expected to be able to use the integral method. So I'm going to integrate the bar from 0 to L of the density of the bar, which is uniform density, times the cross-sectional area, which is also uniform, times x squared dx, plus the moment of inertia of disk, but I'm going to have to use the parallel axis theorem because it's not about its center of mass, it's about this point over here. So I'm going to have to use the moment of inertia about the center of mass, 1/2 mr squared, plus the moment of inertia, plus m times d squared. And d is going to be the distance from here to here. This distance is 3r, so we'll have 3r squared there. So the next thing, we're going to do our integral. This stuff's kind of already in the form we want it in. So I'm going to do my integral here, and so I'm going to integrate this so I'll get density, cross-sectional area, L cubed over 3. Okay. Now what we want to look for is, this L, let's make that what it's supposed to be. L is 2r. 2r. We're looking for a pal. Pal is our mass. So I'm going to factor out a pal, and so I have rho cross-section area 2r, that's my pal, that's going to be my mass, 1/3 2r squared plus the rest of that stuff in parentheses over there. Okay. This is also plus the rest of that stuff in parentheses. So now I'm going to factor that out. That is going to be an m. So I now have 2 squared is 4/3 ml squared, mr squared. All right, plus over here I have 1/2 mr squared plus 9 mr squared. So now I just need to go ahead and combine this all together. Okay, so let's go ahead and figure that out. So we have 4/3 plus 1/2 plus 9 all times mr squared. Now this is going to give us a beautiful function. So this gives us 10.8. I'm sure there's a fraction for it. 10.8 mr squared is going to be our I total for this. Now I guess if you did want a fraction, (65/6), of course. All right, so 10.8 I'll go with. 10.83 repeating. So whenever you have multiple objects, you just have to add their moments of inertia together. With a rod, you can use the integral method to find the moment of inertia about any point with the along the length of the rod, okay, along that kind of a vector. And then for the disk, we're going to use the parallel axis theorem to find that moment of inertia there. There you go.